Hi guys. So we're talking about an introduction to data. That's some of our asynchronous work for September 6th, which is the first class on space exploration. So data is really important in this class, right? It's going to show up in some of your readings. I try not to give too much data heavy work, but it does sneak in, especially when we talk about public opinion. You're going to see some polling data. Specifically in some readings from Pew Research, among others, I think. Definitely, I know I assigned you some Pew Research polling data. They do a really good job explaining their polling, but if you want to look at the data, you need to understand how to use it, right? It's also helpful to understand how to find some of this data because you're going to be writing research papers, and you may want to find some data points to help build your argument. Now, I know this seems really early, right? You don't even have a topic picked yet. Why are we talking about the data you might use to answer a research question? Because I want you to be able to keep in mind what resources you have so that when you pick a topic, you just have an idea. I want to talk about this particular thing with respect to, I don't know, social media and politics. Now, if you want to see how social media affects politics, it helps to know that somewhere out there someone has asked the question, maybe in a poll or something, about how many registered voters are on Facebook. Do they see political news on Facebook? Right? Things like that. So you don't have to do this before your topic proposal, certainly, right? When you send in your topic proposal, which should only be a couple sentences, if it's a topic that lends itself to that kind of data, I can always point you in the right direction. And it might be a topic that there is no data for, which is perfectly fine too. And we can always talk about that if you want to data, how you might find it. And if you don't, that's cool too. So right now, we're just going to look at some preliminary places you can find data and discuss how to use it. So one place is ICPSR. So what I did is I just took the topic for today's class, space exploration, figured, well, NASA is pretty much the primary vehicle of space exploration in the US, and typed in NASA to their search of polling questions, right? They will search all the polling questions in their database and come up with a list of all the questions that have asked about NASA. This one struck me as interesting, so I picked this. It was from a survey done in 1990, and it asked people, over the past few years, did the federal government spend more money on the National Aeronautics and Space Administration, NASA, or Social Security? About 61% of the people said that the US government spends more money on NASA. About 28% said they spend more money on Social Security, 2% said the same for each, and then the remainder said they just didn't know, right? But that is a large portion of Americans think that NASA gets more money than Social Security. If you add in the other 2%, it says it's about the same. Close to 2/3 of Americans think that Social Security does not get more money than NASA. Now, is this true? Are they right? When I saw this, the reason I thought this was interesting is because I was pretty sure they were very wrong, but I didn't know 100% if they were wrong and just how wrong they were. So what I did is I looked up the US federal budget for 1990. And this kind of data can be found on the St. Louis Fed Reserve, or FRED. They have this lovely system that gives you all sorts of economic data, including US budget, or US federal spending, I should say. Now, they don't break it down by department, so I then had to look up NASA and Social Security separately. I just Googled 1990 NASA budget and 1990 Social Security budget. The Guardian, which is a very reliable source for this kind of thing, UK periodical, has NASA's budget, and Social Security Administration, who obviously administers Social Security, has the budget for Social Security. So the US spent approximately 1% of its money in 1990 on NASA and 20% on Social Security. So an entire fifth of federal spending in 1990 was spent on Social Security. and only 1% was spent on NASA. So 61% of Americans are wildly wrong, right? And it's not a criticism of them. I mean, I knew they were wrong, but I didn't know they were this wrong. I, off the top of my head, would never have known the budget numbers from 1990. And I study this, and I knew Social Security must be a bigger part of the budget because I teach the budget in my Intro to American class. But I certainly would not have known the numbers. And I obviously am significantly better informed on this than the majority of Americans because, again, I study this. So people who don't study it seem to have a really skewed view. Why is that? How are they so wrong on this? And there are many reasons and a few really good ones. But I'm just going to talk about one reason that I hypothesize might play a role in this misconception. I think the media's agenda setting power changes this. What happens is the media talks about NASA a lot more than Social Security, and that makes people think NASA is sort of more important, doing more, and therefore must spend more money, right? Seems like a logical sort of leap there. If the media talks about it more, they must be getting more money. Now, of course, to support this hypothesis, I actually need to know that the media talks about them more. I do not know this. So what I did is I went to the Comparative Agendas Project. And they have all sorts of data sets. A lot of data on legislative and executive politics and laws. So they have roll call votes from the legislature, executive orders, State of the Unions, that sort of thing. And they have it also for other countries, right? That's why it's Comparative Agendas Project. So they have this data. You can compare you can compare this across countries, which is really cool. But obviously, to answer our question, why do 61% of Americans think that NASA gets more money than Social Security, even though Social Security is 20% of the budget and NASA is 1%, right? These numbers are from 1990, so they may have shifted slightly by now. But why? Well, like I said, newspaper coverage, right? Or media coverage. So the best way we can approximate that with the data available is by looking at the New York Times front page coverage. Now, it turns out that they only have New York Times data back to 1996. They have a lot of other data back much further. So we're going to have to extrapolate from this a bit. But you can see that only in 1 year, 2005, did New York Times front page stories about social welfare, elderly assistance, Social Security, outpace New York Times front page stories on technology, space travel, right? So odds are that this trend continued back to the 90s, right? Because 1990 was the very tail end of the Cold War. Space race was pretty much over by this point, but still there was a lot of that mentality left. It seems very likely that this trend would hold looking back for not 4 years, but for years prior to this. So it seems like a good hypothesis. There are many, many other hypotheses out there, right? This is by no means the only explanation, but it seems like a reasonably plausible one given what we've read about agenda setting and the data that I've presented here. Again, right, not the only story, just one of them. So data like that polling information I gave you is often presented as a single number, right? It's important to know what that single number means because that single number has a margin of error. Typical margin of error on a political poll is between 2.5% and say 4%. It can get bigger, it almost never gets smaller. And this margin of error is statistically calculated based on the sample size. So we can see that the CNN poll that I've highlighted, it's from 2012. It's actually more than 5 years ago, but that's when I took the screenshot. Actually has a margin of error of plus or minus 3 percentage points for the entire sample. They've done some subsamples of it with interviews, but that's not the number we're dealing with here. Because what we're doing is we're going to look at the single number they give us, Obama up 6 points over Romney. They base this off of Obama's polling at 52% of likely voters, whereas Romney's at 46%. So again, though, that's plus or minus 3 points. It's not quite so clear. And actually, that margin of error is for a 95% confidence interval, meaning that we are only 95% confident that plus or minus 3 actually is going to make this number encompass the actual number if we were to be able to ask every American. So basically what we were actually saying here is with 95% confidence, we can say that Obama had the support of 49 to 55% of likely voters and that Romney had the support of 43 to 49% of the group. So not quite as dramatic as 6 points up over Romney, right? Could be a landslide victory, 55 to 43, or it could be a dead heat, 49 to 49, right? And our polling actually does not tell us where in the margin of error the real number falls, right? And again, with 95% confidence interval, it's not even telling us that margin of error for sure, right? If we were to take 100 samples of Americans and ask them the same question, 5 times out of that 100, we would actually see results fall outside the margin of error, statistically speaking. So polls are not perfect, right? And obviously, they're also asking voters a question at a snapshot in time, right? So that's why I said, at the time the poll was taken. So not only are they not perfect in that sense, but we also have to know what they're asking. What was the question that they asked? Probably it was, if the election were held today, which candidate would you vote for? But it could also just be, which candidate do you prefer, right? Questions can be worded differently, and that can really affect how people answer. And Pew Research has some great studies about this, about even the ordering of the same exact questions, but given in different order will produce different results. It's really fascinating, I think. So if you're interested in that at all, we can always talk about it later, like when we talk about polling and public opinion later this semester. But not only does the wording matter and the order of the questions matter, it also matters if people understand the question, right? How they respond to the question hinges on their understanding of the question, right? So that 7-point liberal to conservative question that I gave you, right, on a scale of 1 to 7, how liberal or conservative are you? That depends on your understanding of liberal to conservative, right? And that is not a very clear topic, I should say. What does liberal mean? What does conservative mean? It's contextual. It means something very different in the US than it does in other countries. So typically these polls are polling likely voters, meaning that they are at least registered to vote here in federal elections, so they are citizens, but that doesn't mean that they were born here and socialized here to have sort of an American understanding of liberal and conservative, right? It could be naturalized citizens or even born here but to parents who aren't from here, so they were socialized by their parents to have a different conception of this. But even if we assume everyone has the exact same view of what liberal and conservative means, how do we know what distinguishes very liberal from slightly liberal or just liberal, right? How do you know if you're conservative or very conservative? It's actually a really hard question to answer. There's no sort of objective measure. This is all subjective. Also, what happens, and this is not the data from your class, this is the data from last semester, because there were a couple errors on invalid entries, I should say, on your answers to these questions. So rather than taking a very small subset of the class between the people who didn't answer the invalid entries, I just went with last year's data. You can see that once I forced people with the, 7-point scale, you pick moderate, that's fine. But now, if you said moderate, you really moderate, or do you lean slightly liberal or slightly conservative? Actually, everyone who picked moderate then sort of admitted to leaning, right? So if you just ask them that first 7-point question, you get more moderates. On the other hand, maybe this just made them feel forced into picking, and we do in fact have 3 moderates, not 2 more slightly liberals and 1 more slightly conservative, right? Maybe they really are truly moderate and just felt forced into picking. So understanding how people respond is important. And understanding what the poll is asking helps us understand how they might respond. Now, one big sort of flaw in a lot of data analysis is that correlation is not causation. Correlation, right, when 2 numbers, go up, one goes up, the other goes up, one goes up, the other goes down, technically negative correlation, right? Just because that occurs does not mean one is causing the other. It may be an indication that they are linked in some way. It may even be a hint that one is causing the other, but it is not a guarantee that one is causing the other. Now, there's a classic example of this. A reporter observes that over the prior month, ice cream sales and murder rates had both increased. So he runs the headline, "Ice cream consumption causes homicide." Probably pretty unlikely, right? Now, he was correct. Ice cream sales and murder rates do tend to be correlated, right? They go up at the same time, they go down at the same time. But it doesn't seem likely that ice cream, you go out and you have a Mr. Softy and now you just have to murder someone, right? Seems pretty odd. The flip side could be true, right? Sometimes people just get the causal arrow wrong. Cause goes in the other direction. Homicide causes ice cream consumption. Okay, also probably not, right? It's not like, oh, I've committed a murder and now I'd like a nice ice cream cone. Seems, again, pretty implausible. So what's going on? Why are these 2 correlated? Why do ice cream consumption and homicide rates go up at the same time, go down at the same time? I want you guys to think about that. Think about what else might be going on. Sorry. So there's a related logical fallacy, post hoc ergo propter hoc. Giving you the Latin, because if you ever take the GRE, I strongly recommend shoving that Latin phrase into the analytical essay. They always have analysis based on that fallacy, and it's fancy to use Latin. They like that. If you're not taking the GRE, well, now you have a fancy term. Basically what this is saying, post hoc ergo propter hoc, means after it, therefore because of it. And it's just basically this fallacy that just because something happens after a thing, it's caused by the thing, right? So this relates to our correlation causation, because just because there's a temporal correlation, A happens before B, does not mean that B happened because of A, right? And a good way of looking at this, thinking about it, is by looking at Congress, right? So let's say that a Congress member, I'll give a different example than what's on here. Let's say a Congress member gets money from the NRA and wins an open seat election, and now he's in Congress, or she is in Congress, and votes against an assault weapons ban. Did they vote against the assault weapons ban because they were bought and paid for by the NRA? In other words, did that vote, just because it happened after the NRA gave them money, did it happen because the NRA gave them money? Actually, probably not, right? What probably happened is the NRA found this candidate who was very anti-assault weapons ban and gave them money to ensure that this candidate, who already had said, I would vote against an assault weapons ban, then ends up in Congress so that they can then vote against the assault weapons ban, right? So the donation and the vote were both caused by this person's pre-existing opinion that there shouldn't be an assault weapons ban, right? So that actually tends to be what's happening. But a lot of people fall into the post hoc ergo propter hoc fallacy and just assume that Congress is bought and paid for by special interest. We can talk about this a bit. I think I actually assign you a very small excerpt of Paul and Wayman's Buying Time later in the semester. So we'll talk about this more then. Now, I mentioned extrapolation when we were talking about the New York Times. I said it was people's opinion on the NASA budget, right? I said it was probably safe to extrapolate from that data. And it probably was, right? There was a very clear trend, and knowing what I know about historical events, if anything, that trend would have only gotten stronger looking further back. But we can't always extrapolate from incomplete data, right? Sometimes extrapolation can be really bad. So maybe we can say, because Biden is polling higher than Trump now, very early September, right? He'll win in November. But maybe we can't, right? That's possibly good. We know that most people's opinions are actually sort of solidified by the time we hit the end of the convention period, which is, conventions have come and gone. And we know that pretty much everyone knows who Biden and Trump are. These are not unknown figures. So probably people are going to have opinions on them already. And it's unlikely that any information is going to come out about either of them that dramatically changes anyone's views. But 2 months is a long time. And certainly if this year has taught us anything, it's taught us that a lot can happen in 2 months, right? I mean, when January hit, no one thought in 2 months the world would be in 2 months from then, the world would be in the middle of a pandemic. And I don't even think 2 months ago, everyone would have predicted that we'd be teaching this class online. I kind of did. I was pretty sure it was going to happen this way, but still, right? It's really hard to extrapolate from data. A lot can happen. So, take these polling numbers, as we kind of already implied, take them with a grain of salt. So finally, statistics can be presented to tell us pretty much anything. I think this quote is wrong. I think it's lies, damned lies in statistics, but you get my point. Statistics can be used to prove or say almost anything, right? You can state a statistic, and if you state it sort of with enough confidence, it can seem like a much bigger deal than it is. It can also really be misleading, especially if they're framed in certain ways, right? Speaking of framing, for another topic from this week, right? So there was a study done that showed that doctors are more likely to promote a treatment with a 40% cure rate than a 60% fail rate, even though that is the same rate, right? 40% cure means a 60% fail. But when it's framed in the positive, 40% of people get cured. Hey, that's not too bad. Not amazing, but it's better than 0% of people getting cured, right? When it's framed that way, doctors are more likely to want to recommend it than if it's framed as a 60% failure rate. Even, 60% failure. Wait, more than half the people don't benefit from this treatment? That's not a very good treatment. Right? So it's just the way it's framed, right? Data can be used to say all sorts of things. So just always be on the lookout for that, whether it's when you're writing your papers, when you're reading articles for this class, or when you're just in life. Always keep an eye out for how people are using statistics.